Hi guys, welcome back to another episode of Introduction to Computer Networks. This is Polly streaming live from NTU again. Very good to see you. Excuse Polly's Chinese typing. I'm just not good at it. Never been good at it and still not good at it. Okay, so hi Bo Yun Yong Yi. Yeah, I was looking for Yong Yi's Yong, that character. And then I mishit the enter. Ouch. Yeah, Yong Yi. Okay, I promised that I would type your Yong correctly next time. And 志祥、竹勋、Tasha、陈恩、庭轩、燕佳 and Matthew. All right, all welcome. And let's check out the announcements, all right? So this is announcement number 3, the general reminder category, right? Good news is that no PA is doing this week, but we do have 5 and maybe 4 quizzes to be due by Saturday. Okay, there are more than usual, but I think 4 out of the 5 quizzes are somewhat straightforward. Now, announcement number 4. So this is the gentle heads up category. Okay, so what I'm trying to do is here, reminding you that PA3, although it's not due this week, and it's due next week, it is, however, challenging. Okay, so you want to click into the PA3 channel and see that Polly has already posted a couple notes there. Okay, and the key point is this: for PA3.go, you want to, of course, work on your solution PA3.go locally on your machine because that's easier. You want to debug on your local machine, but you will need to upload PA3.go to the PA workstation. And for PA3, you need to also test your PA3.go on the PA workstation using this text file, pa3-test.txt file. And this file is already in your team account's home directory conveniently. All right, so you don't need to download it somewhere to your local machine and upload it again. In fact, I would like you to test your pa3.go on the file in your home directory exactly. Okay, so this is to save you the trouble of handling the text file formats, because these text files, although they all come in .txt subfile name, but they can be in different formats depending on the operating system you use, depending on the editor you use to generate this text file. Okay, so to save you time, we'll just accept your pa3.go if you can test your pa3.go on the PA workstation using exactly this file in the home directory. So you can move this file to the pa3 subdirectory. All right, good. And so Polly explains also in more detail why. Okay, we just need to test your pa3.go using this text file. Okay, good. So that was PA3. And another heads up is this, exam 1. The first exam is coming up in about 2 weeks. So we do have 3 exams, unlike the other courses, typically 2 exams. So the first exam is coming up. Okay, so if you click into the exam 1 channel here over here, okay, you will see that it's going to be March 27, end of March. And it will be the lecture time, Wednesday morning. And the exams is going to be served as a Google form. So you definitely want to try these all exam Google form out so you are a little bit more familiar with the process of filling a Google form, a long Google form. All right, and during the exam, you will also need to tune into a Google Meet session. And that is exactly this that you're seeing on the upper right of your screen. And you will need to have a camera showing your face from shoulder up. Okay, and Polly also explained why that's necessary. And this is a very typical requirement for an online exam. Okay, so you would need to have a camera, working camera, when you're doing the exam, and that camera will be taking your headshot from shoulder up. Okay, it can be sideways, it can be a little bit upward, downward, but we need to see your face. Okay, and so you want to test your camera out. Okay, and there's a testing session next Wednesday, right after the lecture. So after the lecture, before you go to lunch, you might want to try quickly tuning to this Google Meet session, and Polly will let you know the camera is working or not. Okay, and so you might want to go to the place you plan to take the exam, so the network condition will be tested as well. Okay, and you want to also try out the environment, because it might not be a good thing if you are doing the test in a noisy, in an environment where the background is really noisy. Okay, so go somewhere the network connectivity is stable, and you can somehow find a power plug, just in case. Okay, and the exam scope. It will cover PA123. Recall at the beginning of the semester, there will be problem sets in the exam that would test your programming skill. Okay, these programming skills that you've learned from working on PA123. So if you guys distribute work among the team members, so those who are not in charge of PA2 or 3, you definitely want to work on PA2 and 3 yourself, otherwise you might have trouble answering these problem sets concerning PA2 and 3. Now, in terms of theory, we'll cover textbook chapter 1.1 to 1.4, which we would finish today. Okay, and starting tomorrow, or maybe starting later today, we'll start talking about chapter 2. Now, to which chapter of chapter 2 that we'll cover in the exam, we'll wait until the end of next week to be more sure. Okay, so the end of the scope is to be determined. All right. So these are the announcements this week. And more hellos to Yo Xuan, Ming Huang, Cassandra, Yuting, Ali, and Lucas. All right. So hope that you all capture these, heads up, PA3 and exam 1. All right, the topics today, there's just going to be 2 parts. The first part is to finish chapter 1. And we'll just teach to chapter 1.5 and not cover the security part. And that overview of security is a little bit too brief and maybe a little bit outdated. So we'll just skip that one. Okay, so guys, if you're really interested in network security, definitely take an entry-level course about network security. Okay. So for the first part, let's start by finishing the topic we left off last week. Recall that we introduced this thing called INET service model. What is this? This is that layer architecture of how we store the protocols, okay, on the internet, right? Internet is a complex system. The number of protocols we have there, it's also quite a high number. Okay, to organize such a complex system, we usually come up with a certain structure. And for the internet, we use a layered structure that is very similar to the example we talked about, the air travel, right? So we have ticketing, packaging, gating, and then maybe routing. Yeah, and the function of one layer depends on the function a layer below. And that is the perfect model for internet protocols, because exactly the higher layer function depends on the lower layer function, and so on and so forth. Okay. Today, this video, this is actually the last video of the internet service model. It is just to be more explicit about the benefits of having such a layered structure. So there are 2. Definitely pay attention. This is a commonly asked question in the exam. Hopefully with the air travel example you see, in large complex systems where we have lots of these pieces, it's really good to have some explicit structure. so that it's a little bit easier to identify in case there's a bug, which piece the bug is, and to find out what are the related pieces might be partly to blame as well. So having explicit structure, really good. And you see in the air travel example, we have this layered architecture, layered service model. That's exactly what we're using, okay, to manage, to organize internet's operation. And we call that layered service model also the reference model, because we are referring to these pieces on the internet in layers as well. Okay, so it's our reference model for discussion among the network engineers, okay, which you are becoming one as well. All right. So this way of trying to break a large complex systems into pieces, okay, and to define, okay, the functionality of each piece is also called the modularization. All right. So after defining the functionality of each pieces, after finding out the relationship between the pieces, okay, we implement the individual modules functionality. We also implement the interfaces to communicate from module to module. Okay, so that is called modularization. Okay, this is really common. We see in large software systems. Okay, because it's a lot easier to maintain. It's a lot easier to debug problems. And it's also a lot easier to improve the system, to move a complex system forward. Okay, because you see, the important functionalities are well modularized. So if we need to change the way we implement the functionality, we can just change it. Okay, and that change does not need to propagate through the entire system across the different modules. Okay, so a change, okay, in a layers service, a change within a piece, a change within a module, okay, can be transparent to the other modules. Okay, because the APIs are already well defined. There's minimum communications required. All right, so it's just like this. Here's an example. If we change the gating procedure and we decided that we let the first class passengers to go last, hey, it's not going to change how the pilots communicate with the traffic control, right, in order to find out which runway to take off. So each module more or less independent, and the communication across modules, across layers, are minimal. Modularization, or layered reference model, layered service model. Sounds nice. Can you think of anything that suggests such a layering is not exactly good? All right. Hey, if you can come up with the drawback of doing such a layered structure, type it up on the chat or go to the score. Type it up in the random channel. All right. So I'll let you guys ponder about the potential drawbacks of doing this modularization or layered structure. Okay. Next topic is Internet Protocol Stack. Now we have protocols sorted, and there are one layer on top of each other. The whole thing is a stack, and that is called exactly the Internet Protocol Stack. So next video, it's 3 minutes. It's Polly's crash course introducing the INET protocol stack. For each layer, I briefly talk about the functionality and provide a couple examples. Here's the Internet protocol stack, and you see here what I'm illustrating. It's in the layered architecture. The layer at the top is the application layer. So these protocols at the application layers are, okay, literally to support the applications. For example, HTTP is supporting the web application. So you do have application processes sitting on the web browser side and another application layer process at the web server side. Okay, and there's a protocol there. For example, a message go out is necessary from the client to request for a web page, right? And that web page will be another message coming back the other way. Well, that's pretty much what HTTP defines. Right? So these messages to control when to start sending and which web pages to send. Transport layer, that's one layer down. Okay, the functionality is essentially to allow these application layer protocols to specify, okay, whether these data that I'll be sending through, these data packets I'll be sending through the internet is going to be reliably transferred or best effort transferred. Okay, so this is to administer data transfer from client to server process or vice versa. Network layer protocols, on the other hand, very special. Yeah, all these packets, oh, by the way, packets, when it arrive at the network layer, it's called another name, datagram. So these packets coming from the source, right, needs to find a way to the destination. You see, at the core of the internet, we do have a mesh of interconnected routers, don't we? A router could have multiple connections to other routers. So each router will need to know, okay, which is the right router to forward next so that the packet will arrive at the destination with the shortest distance possible, right? Because you do want the packets to arrive at the destination as soon as possible. So a good routing protocol is to ensure something like this. So network layer, the protocols there are essentially to handle packets being forwarded and the directions of how these packets being forwarded in the core. Link layer protocol. Okay, so these are very special. They work a little bit like, honestly speaking, the transport layer protocols. Okay, transport layer is to handle data transfer from one process to another. Link layer protocol here also handle data transfer, but it's between one network element to another one network element, one network hardware to another network hardware, or a network entity to another. For example, between two routers directly adjacent to each other, there's just one link. Okay, so this might across several hops at the transport layer, but link layer protocol only handles data transfer in one hop. Okay, so it deals with the data transfer very locally within a link. For example, Ethernet is a link layer technology, a link layer protocol. All right, so internet protocol stack, and you know, during the video playing, yeah, one of you guys posted on the random channel saying that hey, there's a drawback doing the layer structure because when you modularize things, there could be some optimizations you couldn't do, cross-layer optimization. Yeah, okay. So this might help improving the time, improving the reliability, but when you modularize it, it's harder to do. Okay, very good, thank you. And let's come back here. And the last video, okay, of chapter 1 is this. It is actually to show you how data, okay, over the internet travel vertically across protocol stack and then horizontally from hardware component to component, and then vertically again, and then horizontally again from the hardware to hardware, and then vertically again through the software protocol stack, dynamically from the source to the destination. So the video is a little bit long, but if you watch it through, you will get a much better idea how data are flowing through the internet. With the layered architecture explained, what I'm showing here is the software side of the internet side by side with the hardware of the internet. So where are the hardware in this example? Look, here, and here, and here. So these are end systems, okay? This one is the source, and this one is the destination. You see that at the end systems, the entire internet protocol stack is implemented and running. Similarly for the other end system. But in the core of the internet, you see the router over here, and this is a very special entity, hardware entity, it's called switch. But to be precise, this is the link layer switch. Its functionality is limited. Okay? Unlike router, this is a network layer device that implements the protocol stack from the lowest up to the network layer. The link layer switch is a more limited device. It implements only from the physical to the link layer. Well, then you see how it gets the name. It's a link layer switch. And if you want to be precise, you can also call these routers the network layer routers. Or sometimes we actually call these routers network layer switches. Okay, so both of these entities are doing switching, but doing the switching at a slightly different level. All right, now walk with me and let's see how the data gets passed down the protocol stack, out of a physical entity, and through the network, reaching the destination. The first step is this. Yeah, one particular user typing things up. So at the application layer, this component generates a message. Yeah, a packet at the application layer is referred to as a message. The application layer component will pass the message down. As the message arrives at the transport layer, a header is being appended in front of the message. Okay, because it's appending, therefore these additional pieces of information is referred to as the header. H stands for header. And this is a header appended by the transport layer, therefore HT. The whole thing together, this packet, is referred to as the segment. So a packet at the transport layer is called a segment. And you see that this header here is very important. This is to allow the transport layer component at the source side to communicate with the transport layer component at the destination side. Okay, so this is a little bit like at the airport when we're checking our bag. The counter is going to give us back what? The passport, the e-ticket, and what? The baggage claim ticket. Okay, so that baggage claim ticket, that additional information, okay, in order for you to find your bag, is a little bit like the headers. Okay. And now the segment is going to be passed further down to the network layer. And guess what? The network layer component is going to append some more information to it. And that is in the header as well. But this is the header for the network layer, HN. And the whole thing now, the packet here at the network layer is called a datagram. And the whole datagram is going to be passed down further to the link layer. And guess what? The link layer header is going to be appended, and we call a packet at the link layer a frame. So this frame here, now arriving at the physical layer, what physical layer is doing is simply modulating the 0 and 1 bits, okay, onto the physical media. So it's going to go out shortly through the network interface and arriving at the router here. Now I'm skipping the switch here because it's a link layer device. We'll not be able to cover the link layer chapter. So this message is going to arrive here at the router, receive at this physical layer, and the signals gets converted to the digital form. So we restore the original frame back, and that's passed up into the link layer. The link layer at the router is going to examine this header and see if there's any additional function that it needs to perform. When everything is done, guess what? Okay, this header is going to be removed. So only the message with the transport layer header and the network layer header will be passed up to the network layer. You see here, the message is being passed upwards, okay? Because the network layer component of the router still needs to check this, okay, and see if there's something that the network component needs to do at the router. So this is going to be examined, okay, and functionality is performed. Now this part, hey, as this is a router, there's no other layers above. So this is going to be copied over, okay, and stand by there at the outgoing interface. Now before that message go down to the lower layer, the new network layer header is appended. And this one is a datagram. It gets passed down to the link layer header appended. And this is a frame. It goes to the physical layer, bits modulated, traveling the link and reaching the destination. Similarly, the physical layer is going to recover the 0 and bits and give this up to the link layer. This checked by the link layer, and the remaining gets passed up to the network layer. And you see this removed, this part gets passed up to the transport layer. This removed, and this part here gets passed up to the application layer. And here, the destinations processed there at the application layer finally see the message coming from the source originally. So this is how a message travels through the protocol stack and the physical infrastructure, and more protocol stack up and down until all the way up to the application layer at the destination. All right, so I nicknamed that the life of a packet, okay, in the internet. Now, chapter 2. So this is the second set of topics today. Okay, the first video is just Polly going through these network applications that we've been using already these days. To make sure that we're in sync, let's inventory some of the popular network applications here. Email, web, nothing more to be said. They are obviously email and web. Text messaging, Line, WhatsApp, What else? A Google Messenger. And if you guys are watching this from a YouTube live stream, that chat room is a text messaging app. Remote logging. If you downloaded a client to remote logging to the PA server, then you're using a remote logging application or remote logging service. P2P file sharing, the most well-known one, BitTorrent. Okay. Multi-user network games. Okay, so this is a more formal way of calling online games. Okay, so some of these online games are running on desktops, going to the game server somewhere provided by the game company. The client can be nowadays running on smartphones. In fact, probably more games people are playing are mobile games. Okay, so the client is on the mobile platform. And then the multimedia applications. Here we have the streaming stored video, and we have the real-time voice. So this is also called the voice over IP. And we have the real-time video. Okay, well, real-time video conferencing, of course, also comes with audio. Okay, so essentially these three are multimedia applications. The difference between this and these other two is that the video is actually a playback video. So the video is already stored in one of the video content server. And when you request it, it is just playing back the video. But for these are the live video being generated as you guys are having conversation, as we are having conversations. So the delay requirement for live audio video is a little bit higher, more stringent. So what do we have as real-time video conferencing apps? Yeah, Google Me, the one we have standing by here, allowing you guys to call in, is a real-time video conferencing app. So there are other real-time video conferencing apps such as Zoom, Microsoft Teams. What else? Well, Skype. Although transfer audio, it also transfer video. So Skype is also a real-time video conferencing app. So there are many options here. Social networking. Hey, Facebook, IG. One can probably come up with others such as Snapchat. Yeah, so there are just increasingly more of these social networking apps. Search, Google Search or Bing. Yeah, each of these is also an application or a network service. Cloud computing, yeah, Amazon AWS, for example, is a cloud service. And that takes us to the quiz today. This is quiz number 7. Okay, let's check out what this is about. Yeah, so every year, Polly will survey the young generation so that she keeps herself in sync with the society. Okay, and what's nice about teaching in college is this: I got access to you guys. Okay, so could you tell me, okay, the top 2 network applications you usually use on a PC or laptop? So these are more or less stationary computers. And Q2. Tell me the 2 network apps that you use often on smartphone. Okay, so this is very mobile. And the 2 games you play on any of the platforms. Okay? So this, again, hey, many of the quizzes this week, straightforward. Okay, so let's go to the score space, channel W4, quiz 7. So this is open-ended, obviously, and it's straightforward. So I was not looking for fast response. I was not looking for thoughtful response either. Okay, but I do like your participation. So guys, gather your teammates. You guys have 4 minutes to discuss and converge, and 1 minute to type up your answer. Now, in case there's enough time, and some of the members would like to add to the solution posted by the representative this week, you just reply to the post, okay? Yeah, if you want to add to the solution posted by the team's rep, just reply to the post. And so, 4 minutes plus 1 to tie things up. Let's start counting time. Tetris? Apple Music, Instagram, Threads. All right, time's up. Yeah, I see that Noe wants to add. Feel free to just add or post or reply to your team's post. Mm. Yeah, I've already seen some interesting replies and some applications that I don't know of. Ooh, ouch. Okay, so Team 7, Yuan Hao, your apps I've heard: YouTube, Facebook, Dcard, and Instagram. But you obviously like transportation systems, the games you play, right? Motorways and air traffic controller. Yeah, probably likes also transportation systems. And team number 4, Telegram. Okay, guys, you want to be careful using Telegram these days, though. Okay, Twitter and Instagram. Yeah, by the way, Ali, not many Taiwanese use Twitter. But it was very commonly used rest of the world. Overcooked. Brawl Stars. Oh, okay. I've heard about Overcooked, but Brawl Star. I'll look it up. Okay. So these look like games that kill time, I guess, session based. And then Team 17, Google Meet and Discord. Line, yeah, WhatsApp. Clash Royale, interesting. Arena of War. And then team number A. Okay, team number A seriously is using NTU Cool a lot on a laptop or desktop. Wow, you guys study hard. Good for you. Okay, the game. That sounds fun. Yeah, because this is probably simulating the sound. Okay. Casual fighting game. Oh, okay. Is it like Street Fighter? Fighting games, I know. By the way, there's a Taiwanese winning the Street Fighter 6 champion. The Capcom 10 Cup. I mean, he doesn't look like a champion, but he is the champion. Okay, very interesting, guys. Hill climb, interesting. And you know what? Yo, Xuan, Clara, I live in your generation. I played Tetris too when I was being my teenager. Yeah. Like Candy Crush, I see. Thank you, Sutan, for adding to that. 13. The score in Apple Music? Ah, okay. Yeah, yeah. Music is always playing on my app as well, on my smartphone as well. What is threads? Interesting. I'll look it up. All right. Oh, I see here. I see. Qingying doesn't play a game. Oh, what a good student. But Vincent plays LOL and the fighting game that Ali was talking about, right? Yeah, interesting. Very good to know. Racing game here, I guess. Zhuxun, you read Reddit? Okay. I guess there are more and more Taiwanese on Reddit these days. Line only. Yuting. For communication purpose, I suppose. Okay, Yuting, the games you play? Oh, completely new to me. I need an update, definitely. Twitter? Yeah, of course, Zhixiang. To be correct, it's X nowadays. Yes. Minesweeper, classic game. Okay, I can see that the apps you use on the laptops are kind of similar, right? The Score, YouTube, Google Me. And then on the smartphones, mostly communication, right? IG, Messenger, Facebook, Line. Ryan, email. All right. FYI, Taiwanese don't use email. I mean, hey, I wouldn't say not anymore, but just not using it unless it's necessary. Oh, you play chess? Okay, cool. Messenger, Instagram, LOL. It seems still very popular, this game. LOL. FC Mobile. Okay, Cassandra gets a lot of support from the teammates. Genshin Impact. I've heard about this game. It was popular for a while. Valorant. I've heard about this one also, but from last semester from the students in the class as well. All right, guys, thank you for the input. Grand Theft Auto? Not enough time. Oh man, sorry. Okay, Junhuan. LOL, Valorant. Yeah, but okay. I guess LOL is universal. Yeah, there's like a league. Teams from all over the world compete. Yeah. Okay, good. I get a very good idea already. Thank you. Yeah, thank you also for the additional input from the teammates, okay, on top of the Rap's original post. You know what, guys? These are all network apps, okay? All these things that you use are networked, and they all require the internet to work. Okay, so you see that network applications, it's something that concerns our life very much. And I kind of envision some of you guys turned out to be an app developer as well. Okay, so this video is to give you an idea, the principle of how these network applications work. Now, to support all these applications, the principle is quite straightforward. Essentially, we write programs. There involves at least two parties. One program sits on one of the parties. Particularly, each of the programs sits on each of the end systems involving the communication. Okay, so they will be communicating, sending messages over the internet. So for example, web server program sits on the web server machine. Browser sits on the client machine. And these two programs send messages to each other. Much like this. So we might have a web client here. We might have another web client here. And the web server is down here. And we establish connections like this. So this client's program interact with the server's server program. This client's program interact with the program running on the server as well. Okay, so you see that the server program here needs to be a little bit more powerful, allowing requests from these clients, okay, frequently and potentially simultaneously. So essentially, in order to create these network applications, we design how the messages are exchanged, meaning designing an application layer protocol. Afterwards, we program the softwares. There'll be one part running on one end, the other part running on the other end. So this example here is a client-server application. For P2P, one runs on peer, the other runs on another peer. But in P2P, these two programs usually are identical because they are both peers. Now, what's unique here is this. Applications run only on the end systems. In the network core, these routers, the routers do not run anything particular for a particular application. Okay, so the core devices do not run applications. They do not run specific functions to support individual application. Okay, so applications are strictly on the end systems. So clients, limited devices such as a smartphone, such as a laptop or desktop, are on the edge of the internet. But you see here, servers, more powerful machines, they can be quite expensive. Some of them can be just as expensive as the routers. But these servers are also at the edge of the internet. They are also end systems. Just don't be confused. Okay, so these end systems, there are programs running and exchanging data such that we can perform a specific application or specific service. All right, so that's network application. Essentially, you have programs on the end systems and multiple of these so that they will be sending data back and forth to each other. Okay. Now, a little bit more formally, when you are designing a network application, there are a few things you need to define. First is how these programs on different end systems will communicate. Okay, there are different models, different architectures. Okay, that is the video we'll be playing next. But let me just go a little bit further. Second thing you want to do is once you have established the model of communication, to enable the communication, you need to start something called socket. Okay, so these programs, to establish a connection, you call the socket API. That is something that we'll talk about first thing tomorrow morning. Okay. After these two are defined, the messages, the data you're sending, it needs to come in certain format so that either side of the program can understand what the other side is trying to say and potentially respond. Okay, so communication model, socket, and the messages. Okay, so these are the very basic things to compose a network application. So let me talk about the communication model first. There are three of these. First thing we do designing a network application is to decide its structure. There are three general models and we'll go through them one by one. First is the client-server model. In such a model, we have powerful machines we call servers that are always on and running on permanent IP address, therefore always reachable, and sitting in one of these data centers allowing access from users worldwide. Now, on the other hand, we have the clients. These are the devices operated by the end users, such as us. So these are the devices initiating communications to the servers. And they are intermittently connected to the internet as we operating these clients are moving around. And so from one location to another location, we'll be using different IP addresses. That is why the clients do not communicate directly to each other, because the IP addresses that each of these clients is using the next moment can be different. So two examples on the left are first, a driver in a car looking up a route to a particular destination, and she could be accessing the Google Maps server. And this can be a student looking up the PA assignment, then this will be the web server of the course webpage. Second is the P2P model. In such a model, there are no longer always-on servers. All we have are just a bunch of these intermittently connected end systems. These end systems will be communicating directly to each other. And we call these end systems peers because they will be requesting services from other peers. They might also provide services to other peers. That is saying that these peers, these end systems, are not strictly client or strictly server, and each of them play equal parts. So peers are a better way to characterize these end systems. This is what's nice about the P2P model, self-scalability. When a new peer joins the network, as they request for services, you will see that the demands go higher. But they bring also computation or storage capacity, right? So we get more resources as well. This is opposed to the client-server model, where there are more clients joining. The service demands will rise, but the capacity doesn't. Now, on the downside, the peers are all intermittently connected. That means the IP addresses are changing all the time. So you can imagine that it can be a little bit challenging maintaining a continuous connection. Third is the hybrid of the first two models, and this is used by Skype, a voice over IP service that used to be popular. And in Skype, the call in between two users, that is done by a direct connection between the two users and systems. So you can see that it's P2P. But to establish the call, you need to find the address of the user you want to call to. And that is done by querying a centralized server. So you see this part of Skype is client and server. And so Skype is under such a hybrid architecture. All right, so that's architecture communication model. So before you start implementing your app, you want to make sure that you define whether you want a P2P communication there going on or a client server. So, hey guys, that's all the time we have. And thank you for all your feedback for quiz 7. With that said, I say goodbye. I see you tomorrow morning, and we'll go on and talk about the next 2 things you need to define to come up with a network application. Okay, bye. Okay, bye. And by the way, Cassandra is right. I think Taiwanese just use line to communicate, even professionally. And it's kind of invasive to private life, I know. It's very inhumane, but that is the way it is here. Okay, bye. Okay, Yulin, Yulin, I'm not sure. I'm still streaming, so you might appear on the YouTube session. So do you mind wait for a little bit? And let me finish the YouTube session. Then you can go ahead and ask questions. So guys, let me end the stream early today because I'm gonna take some questions. Okay, good. So, see you tomorrow.